Hello guys, my name is John Michael E. Reyes and we are here on the chapter 6 network layer, introduction to network. Then let's proceed. Then chapter 6 objectives. In this chapter you will be able to explain how the network layer protocols and service supports communication across data networks, explain how routers enable, then determine the appropriate device to route traffic in a small to medium-sized business network. Then configure a router with basic configurations. Then chapter 6, these are the chapter 1 network layer protocols. The network layer protocols are, or OSI layer 3 is provide service to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes: addressing end devices, encapsulation, routing, and decapsulating. Network layer protocols, common network are the IPv4 or Internet Protocol version 4 and the IPv6 or Internet Protocol version 6. Then legacy network layer protocols include the Novel Inter-Network Packet Exchange IPX, the Apple Talk Connectionless Network Services CLNS, and DECnet. Then IP components, IP header segments, then the one is TCP segments, encapsulated IP, then other stuff. Then connectionless, no connection is established before sending data packets. Then best effort, unreliable, no overhead is used to guarantee a packet delivery. Then media independent, operates in as from the move itself, operates independently of the medium carrying the data. Then the connectionless, if the receiver is present, if the letter arrive, if the receiver can read. The receiver doesn't know when it is coming, that's why it is connectionless. Then best effort delivery is as an unreliable layer protocol. IP does not guarantee that all sent packet will be received. Other protocol manage the process of tracking packets and ensuring their delivery. Then as you can see in here, the figure. Then IP media independent, as you can see in here, copper ethernet, copper serial, optic fiber, copper ethernet, and wireless. IP packets can travel over different media. Then encapsulating IP, the network layer adds a header so the packet can be routed through complex networks and reach their destination. In TCP or IP based network, the network layer PDU is the IP packet. Then as you can see in here, segment header, then the data, then the IP header, then the IPv4 packet head. As you can see, byte 1 is the version, sorry for that, DS, and this is the packet header of IPv4. Then IPv4 header fields is just like this. And let's proceed. IPv4 headers just like that in the video. Then limitation of IPv4, IP address depletion, internet routing, table expansion, and lack of end-to-end connectivity. Then introducing IPv6. The IPv6 or the Internet Protocol version 6. It increased address spaces, improved packet handling, eliminates the need for NAT, integrated security, and IPv4 has only 4 billion addresses, while IPv6 or Internet Protocol version 6 has 340 undecillion addresses. So as there are so many zeros in here. Then encapsulating IPv6. As you can see in here, the difference between IPv6 and IPv4 is the version, traffic class, flow label, payload length, next header layer, hop limit. Then in here are some still very different. Then IPv6, the version, traffic class, the version is somewhat the binary code. Then the flow label is how they are gonna be labeled, or and traffic class is If there are the same, then the payload length is the bytes, number of bytes. The next header is for the next IP, then the hop limit is in where how many times will it jump, then source IP address and the destination IP address. And this is the example. Then routing, as you can see, host packet forwarding decision. Then default gateway, host must maintain their own local routing table to ensure that the network layer packet are directed to the correct destination network. The local table of host typically contains direct connection, local network route, and local default route. Then these are routing table, as you can see in here. There are default gateway, net mask, interference, metric, and network. Then IPv4 sample. Then hosting router is what when you type in the command prompt the netstats-r, then router packet forwarding decision, the directly connected network, then remote networks R13 directly connected network, as you can see this one, and this one. Then routing, the IPv4 router routing table. If you type the show IP route in the router, this one will appear. Then directly connected routing table entries, as you can see in here. C is connected, then L is labeled, and as you can see in here, they are both connected in the router. Then blue identifies how the network was learned by the router. B identifies the network destination, the destination network, and how it is connected. Identify the interface on the router connected to the destination. Then as you can see in here, these are the routing table entries. D is the one that was learned, network was learned. Then this one is the destination network. Then this one is the administrative distance or the route source. Then this one is the metric to reach the remote network. Then this one is the source or the next hop IP address. Then this one is where the white one is identifies the amount of elapsed time since the network has discovered. Then identifies the outgoing interface of the router in here. Then if you show the IP route, as you can see in here, there are these are the destination, then routers, then in routers, as you can see, these are the sum of the computer routers. Then router CPU and OS, these are the CPU and OS. Then RAM, volatile, running iOS, run configuration file, IP routing and ARP tables, packet buffers, and ROM or it is non-volatile. This stores boot up instruction, basic diagnosis software, limited iOS. Then the NVRAM is a non-volatile, but the only thing that it stores is the startup configuration file. Then flash memory, or it is also a non-volatile RAM, the iOS and other system files. Then inside the router, as you can see, these are the parts of the inside of the router. There are packet supplies, shield for weak, then the fan, SDRAM and VRAM, CPU, and AIM, the advanced integration module. Then in the router backplane, as you can see, double wide EWIC slot, EWIC aux port, and the console RJ for the RJ port 5. Then the LAN interface, USB ports, console USB port type B, and other stuff. 2 4GB flash card slot. Then connecting to a router is the aux port again, one interface, LAN interface for the RJ port 5. Then console USB type B, then serial interface and the LAN interface. Cisco iOS, Cisco OS, operationally details vary on different inter-networking devices depending on the device purpose of the feature. However, Cisco IOS 4 router provides the following: addressing, interface, routing, security, and QoS, and resource, quality of service, and resource management. Then boot set file, as you can see, flash, then RAM and VRAM, startup configuring the running config. Then ROM performs ROM post bootstrap, then as you can see here, bootstrap process. Then show, if you type the show version in the router, this thing will show up on you to you, the as you can see in here. Then configuration is, these are the configuration. If you want to rename the router, you could go for host, this one. Then if you want to secure all the lines, these are the encryption that you need if you want to have a banner mode, and if you want to copy the running config into startup or just type right. Then as you can see, it is the LAN interface for the IP addressing of the switches. So you can see here, IP address, it is where you put an IP address in a switch. Then IP add, after that, now shutdown, then exit. Then as you can see, if you type the show IP interface brief, there would be an IP address on every protocols and other stuff, and if you ping one of them, there would be a reply and receive. With default gateway on host, the default gateway is 0.024, then other stuff. Then as you can see in here, it's just the basic configuration. Then if you want to show the running config, you should type the show running dash config, and this would appear. Then summary, in this chapter you learn the network layer or OSI layer 3 provides services to allow end devices to exchange data across the network. The network layer uses 4 basic processes: IP addressing for end devices, encapsulation, routing and decapsulation. The internet is largely based on IPv4, which is still the most widely used network. An IPv4 packet contains the IP header and the payload. The IPv6 simplified header offers several advantages over IPv4, including better routing efficiency, simplified extension, headers, and capabilities for per flow processing. And I think that's all for chapter 6, and thank you for listening.